Chemical reaction engineering. Question 40. A certain drug is metabolized such that its concentration in the bloodstream halves every 4 hours. If the drug loses its effectiveness when the concentration falls to 10% of its initial concentration, how frequently should the drug be taken? Now, as with all problems, what we want to do when initially tackling them is draw a rough diagram. So I have a rough diagram here drawn on Microsoft Excel. And as you can see, concentration is roughly decreasing exponentially with time. So, to start this question, we need to look back at our first order reaction kinetics, where we have dCA over Ca is equal to minus K dt, where K is the reaction constant, dt is the rate of change of time, Ca is the concentration, and dCA is the rate of change of concentration. Now rearranging, we get the following integral, and solving for this integral, we get natural log of Ca minus the natural log of the initial concentration is equal to the rate constant multiplied by time, which gives us this following equation, which can be rearranged to give us this following equation. And finally, we have the equation that the concentration is equal to the initial concentration times the exponential function of minus kT. Now, to solve this equation, we know when time is 4 hours, our concentration is equal to half the initial concentration. Subbing these into the equation we just derived, we get the initial concentration over 2 is equal to the concentration times e to the minus k times 4. Rearranging, we get the following equation, and rearranging again, we get this equation, which gives us k is equal to minus 0.69 over minus 4, which is equal to 0.173. K is equal to 0.173, which, if we go back to our Excel plot, was the rough constant that our Microsoft Excel plot gave us, which is fantastic. We know we are on the right track. Now, to solve the question asked of us, at 10% concentration, the concentration is equal to the initial concentration divided by 10. Subbing these into our equation, we get the initial concentration divided by 10 is equal to the initial concentration times e to the power of minus 0.173 times t. Rearranging, we get the following equation, and rearranging again, we get that minus 0.173 times time is equal to the natural log of 1 over 10, which gives us an equation for time, which solved gives us the answer. Time is equal to 13.29 hours, which is the answer to our original question. Thank you very much.